In this video, we are going to solve problem number 283, which is move zeros. The problem statement is, given an integer array nums, move all zeros to the end of it while maintaining the relative order of the non-zero elements. Important note is, you must do this in place without making a copy of the array. For example, the input given is nums array 0, 1, 0, 3, 12. The expected output is 1, 3, 12, and at last the zeros are moved to the end. If you have a close look, the relative order, that is 1 is followed by 3 and 3 is followed by 12. This is also maintained in the output array. The second example is, if the nums array contains only an element 0, then the output should return only the element 0. Now let us try to finalize the approach how we are going to solve this. Since we have to do this in place, obviously one thing that should click in your mind is, we are going to use two pointers. So what we are going to do is, we are going to initialize the read pointer to 0 and the write pointer to 0. What is the role of the read pointer? The read pointer will scan array for non-zero element. As soon as it encounters a non-zero element, we are going to swap that with nums of write and then update write to move ahead by 1. When read reaches the end, all zeros are moved to the end of the array successfully. So this is just a bare minimum implementation. We have our function const move zeros, which takes an array as an input. We have initialized our two pointers read and write to 0. Here, since read will scan the array till the end, hence we are checking read is less than nums.length. If that is the case, then we check if nums of read, not plus plus, if nums of read, if it is not equal to 0, then we swap the values of the pointers read and write with each other. So this is how you do in-place swapping in case of JavaScript. Once the swapping is complete, we increment the write counter or we move the write pointer ahead by one slot. Now let us implement this. So here we have our move zeros function. So we will initialize read pointer to 0 and write pointer to 0. And inside the m variable, we will store the length of the nums array. Since read will be used to scan the array, so that will be used inside the loop. While read is less than m, then we check if nums of read is not equal to 0. In that case, we swap the elements. In case of JavaScript, this is how we do in-place swapping. That is, nums of read and nums of write is equal to nums of write and then nums of read. Okay, then move the write pointer by one slot. So write plus plus, and after the if condition, we are going to do read plus plus. So that's it. However, we can optimize the swapping as well. Consider a case wherein your array contains only 1, 2, 3. In that case, there will be unnecessary swapping. So to avoid unnecessary swapping, what we are going to do is, we swap the elements if and only if read is not equal to write. That is, both the read and the write pointer are not at the same location. Only then we are going to swap the elements. So this will minimize the number of swaps, making our solution more efficient. Let me save this. Going to LeetCode. Let us copy this nums array. So here After in place, first we will console.log LeetCode array, which is nums. And after the loop has ended, at the end, we are going to print the output array after the in place movement non-zero elements to the front and 0 elements to the end. Let us call our move zeros function passing in this array. Let me open the terminal, and from within the terminal I run nodes. Finally is 283 move zeros.js. Here it is. Input array is 0, 1, 0, 3, 12 and output array is 1, 3, 12, 0, 0. Let us also try this with only the 0 element. With only the 0 element, the output is only the 0 element. Now what we will do, we will add a count variable, let count equal to 0, and we will pass in an array with only non-zero elements 1, 2, 3, 4, 5. In this case, let us here we will increment the count, and at last we will console the number of swaps. Console.log number of swaps made. So this will be count. Let us again run this code. So here it shows number of swaps made 0. Now if we remove this if condition, then let us see what are the number of swaps made by this program. So I have commented the if block. Now let me rerun the code. Here it shows number of swaps made 5. So these are unnecessary swaps because the input array has all the non-zero elements. Hence we have added this if block which ensures there are no unnecessary swaps. So this is how you solve the problem of moving zeros to the end of the array using two-pointer approach. That is, you initialize read and write pointer to 0. You use the read pointer to scan the array. As soon as the nums of read is not equal to 0, you swap the element, and you only swap the element if read and write both are pointing at different locations. Once you have swapped it, you move the write pointer ahead by one slot, and at the end of the loop, you increment the read pointer, and at last we have just added console.log in order to ensure that the optimization that which we have added is indeed working as expected. So thank you all. If you have learned something valuable, please do like, share and subscribe. Thank you.